At the edge of the sun's kingdom, an old metal insect is whispering from a place so empty it should have no voice at all. You would expect a craft this old to fade into silence, not to become more mysterious with every year it survives. Stay with me, because this is not just the story of a dying spacecraft, but the story of a machine that keeps breaking the rules we wrote for it. But before we go deeper, subscribe if you want these deep space stories to keep landing in your feed while the discoveries are still unfolding. Voyager 1 was launched in 1977, when disco filled living rooms, home computers were still rare, and nobody expected this probe to still be awake in 2026. It was built to visit Jupiter and Saturn, not to become the farthest thing humans have ever touched. Yet now it is more than 15 billion miles from Earth, so far away that a message needs almost a full day to reach it, like mailing a thought to the stars and waiting 2 days for the reply. That alone would be enough to make this mission legendary. But the real shock is not that Voyager 1 is still alive. The shock is that it has been sending back signals that looked impossible, then readable, then impossible again in a deeper way. Because the stranger the engineers looked, the stranger the space around it also seemed. Imagine your oldest kitchen clock still ticking after 50 winters. Then one morning it starts telling the wrong time while somehow still keeping your house perfectly on schedule. That is the kind of puzzle Voyager 1 became. And that is why this story matters so much. It is not only about a brave machine limping through the dark. It is about what happens when your oldest tool, the one everyone quietly expects to fail, becomes the only thing listening in a place no one else can reach. When that tool starts speaking nonsense, and then starts revealing new truths anyway, you are forced to ask a harder question. Is the machine failing, or is the universe turning out to be stranger than our neat little guesses? To understand this, we first need to go back a long way. Most people think Voyager 1 is basically a dead museum piece drifting on momentum alone. That is wrong. Voyager 1 is old, yes, but old is not the same as inactive, and drifting is not the same as observing. It still carries instruments, still points a high-gain antenna at Earth, still listens to charged particles, magnetic fields, and plasma waves, and still sends those faint signals home with less power than many small household gadgets use without a second thought. The first surprise was that Voyager 1 was underestimated from the start. It was never built for a 50-year job. It was built for a grand sprint past giant planets, the kind of mission people imagine as fireworks, photographs, and applause. What scientists expected was a brilliant but limited tour. What they actually got was a stubborn traveler that kept going long after the party was over, like a flashlight left in a drawer that still works decades later when the power goes out. Voyager 1 launched on September 5, 1977 at 12:56:01 Universal Time. It weighed about 1,592 pounds, or 721.9 kilograms, about as heavy as a large motorcycle. It carried 3 nuclear power generators, each producing about 158 watts at launch, which is not much when you think about it, just a modest stream of electricity for a machine asked to survive the deep freeze of space. From the beginning, it was a lesson in doing a lot with a little. It even launched after Voyager 2, which sounds backward until you learn that Voyager 1 took the faster route. By December 15, 1977, it had already overtaken its twin. That was the pattern of this mission from the very start. People expected the craft with the later launch to play catch-up. What actually happened was the opposite. It was like the second runner leaving the track later, cutting a sharper corner, and suddenly leading the race into the dark. Then came Jupiter. By April 1978, Voyager 1 was studying the giant world from a range of 165 million miles. On March 5, 1979, at 12:05 UT, it passed Jupiter at about 174,000 miles, close enough to rewrite textbooks. Scientists expected better pictures and some useful measurements. What they actually found included a thin ring around Jupiter and 2 new moons, Thebe and Metis. It was the cosmic version of opening a closet you think you know and finding a whole hidden shelf behind the coats. Saturn was next, and again the old probe overperformed. On November 12, 1980, at 23:46 UT, Voyager 1 passed Saturn at about 78,000 miles. Scientists expected a grand flyby and cleaner views of the rings. What they actually found were 5 new moons, a new ring, and ring structures far more tangled than many had imagined. It was not like reading a book with 1 extra page. It was like opening the back cover and discovering an entire second ending tucked inside. And then something quieter happened, but in the long run it mattered even more. After Saturn, Voyager 1 turned north, out of the flat plane where the planets orbit, and headed for the outer edge of the sun's influence. The cameras were eventually turned off. The postcard phase ended. This is the moment many people lose interest in a mission like this. No more pretty worlds, no more close passes, just a small machine moving into colder and emptier space. That was the second big mistake people made. They thought the interesting part was over. Scientists expected the Interstellar mission, which officially began on January 1, 1990, to be valuable but less dramatic. What actually happened was that the farther Voyager 1 went, the more it became the only witness in a region no other spacecraft had reached. A kitchen gets noisy when everyone is cooking, but the single quiet sound you hear after midnight can tell you even more about the house. By February 17, 1998, Voyager 1 had become the most distant human-made object, passing Pioneer 10. In August 2006, it reached 100 astronomical units from the Sun. 1 astronomical unit means the average distance from Earth to the Sun, about 93 million miles. Those are huge numbers, and numbers that huge can turn your brain to fog. So picture this instead. If Earth and the Sun were 2 lamps across one room, Voyager 1 had gone hundreds of rooms away and was still phoning home. The third discovery puzzled scientists in a different way. On August 25, 2012, Voyager 1 entered interstellar space at about 122 astronomical units, roughly 11 billion miles from the Sun. Scientists expected a clean crossing with several instruments agreeing at once. What they actually got was a half-solved mystery. The particle instruments showed strong clues that the craft had crossed the boundary, but the plasma science instrument on Voyager 1 had stopped working decades earlier, back in 1980, so the clean proof was missing. That missing proof matters. Think of it like hearing water drip behind a wall but losing the one tool that tells you exactly where the pipe broke. The spacecraft had clues, the team had clues, but the simple, direct answer was gone. For almost a year, scientists had to live with a border crossing they believed had happened, but could not confirm in the neatest way. Space is full of moments like that. Not grand certainty, but careful listening in the dark. Then the spacecraft itself helped close the case. Its plasma wave subsystem, a tool that listens to electric vibrations in the thin gas between stars, detected oscillations that showed Voyager 1 was moving into denser plasma. Scientists expected silence, or at least something harder to read. What they actually found was a kind of proof by echo, a faint sign that the space around the craft had changed. It was like walking from one room into another and knowing it not by sight, but by how your footsteps suddenly sound on the floor. What part of this journey hits you hardest so far? The age of the craft, the distance, or the patience it takes to wait 2 days for one answer? Your comment helps me see which part of these deep space stories you most want me to explore next. Keep that thought close, because now the story gets weirder in a way nobody saw coming. Voyager 1 was now outside the Sun's bubble, and many people imagined that meant it had entered pure emptiness. That is, the misconception correction the mission kept forcing on everyone. Interstellar space is not packed like air in your room, but it is not nothing. It has particles, magnetic fields, pressure fronts, and waves. It has weather, in a way. Not clouds and rain, but shifting conditions that can still push, hum, and surprise a machine built during the age of cassette tapes. The fourth discovery came years later, and it sounded almost like a ghost story told in numbers. In 2021, research led by Stella Koch-Ocker of Cornell University reported something faint but important in Nature Astronomy. Scientists expected Voyager 1 to catch only occasional plasma signals triggered by major events, like shocks moving through space. What they actually found was a very weak, narrowband plasma wave emission that had persisted from 2017 onward. Not a shout, more like a steady hum. That hum changed the picture. If earlier signals were like thunderclaps you only hear during storms, this was like the soft sound of a refrigerator at night that tells you the room was never truly silent to begin with. The study, published on May 10, 2021, suggested Voyager 1 was making more continuous measurements of the density of interstellar plasma than scientists had hoped. That is a big deal, because density tells you how the material between stars is arranged, squeezed, or stretched. And here is the surprise pattern again. Scientists expected the local interstellar medium, the matter between stars near our solar system, to be smoother and harder to monitor. What they actually found was structure, motion, and a faint, persistent signal that could trace changing density over long distances. Compress that into an everyday image, and it is like expecting an empty parking lot at dawn, but hearing a low engine note from several cars idling in the fog. The place you thought was quiet is quietly active. This is one reason Voyager 1 matters so much now. It is not only far away, it is alone in the right place with the right ears. NASA, JPL, Caltech, and the Deep Space Network can send commands and receive whispers, but they cannot send another identical witness out there in time to compare notes. Voyager 2 is also in interstellar space, yes, but it is on a different path and living through different power limits. Voyager 1 is the old scout at the fence line. Then came the first wave of truly impossible-seeming data. In 2022, engineers at NASA's Jet Propulsion Laboratory began investigating bad telemetry from Voyager 1's Attitude Articulation and Control System, or AACS. That is the system that keeps the spacecraft oriented correctly and its big dish pointed at Earth. Scientists expected that if the craft could still send a strong signal, the orientation system would report sensible status numbers. What they actually got were readouts that did not match any possible state the system should have been in. This was the kind of problem that makes engineers stare at a screen in silence. The craft appeared to be operating normally. It was still receiving commands. It was still gathering and returning science data. Its signal had not weakened, which strongly suggested the antenna was still aimed at Earth. Yet the numbers coming from the AACS looked random, or at least wrong enough to seem impossible. Imagine your car steering perfectly down the road while the dashboard insists the wheel is spinning in circles. Suzanne Dodd, the Voyager project manager at JPL, said in 2022 that a mystery like this was almost par for the course at this stage of the mission. That sentence sounds calm, but it carries real weight. By then, Voyager 1 was about 14.5 billion miles from Earth, and light took 20 hours and 33 minutes to cross that gap. You do not pop the hood. You do not run a quick test. You send a thought, wait almost a day, and then wait almost another day for the answer. Scientists expected the problem to trigger fault protection or push the craft into safe mode. What actually happened was stranger. The fault systems did not fire. The spacecraft kept acting healthy in all the ways that mattered most. The impossible part was not that Voyager 1 was breaking. The impossible part was that one part of its story was nonsense while the rest still made perfect sense. Like a wall clock that rings every hour on time but claims it is February when it is clearly July. If this old explorer earning one more day in the dark feels worth celebrating, will you like this video and tell me why this mission matters to you? That quick signal helps the YouTube system notice that careful science stories still deserve room to breathe. And Voyager 1 was about to give engineers a much bigger problem than a wrong dashboard. On November 14, 2023, the mystery deepened. Voyager 1 was still sending a steady radio signal to Earth, but the signal no longer carried usable science and engineering data. Scientists expected garbled output to mean a failure so severe that the craft might stop listening too. What they actually found was a probe that still heard commands and still responded in a physical sense, yet returned a stream that made no useful sense to the humans waiting on the ground. The suspected trouble lay in one of Voyager 1's 3 onboard computers, the Flight Data Subsystem, or FDS. This is the computer that packages science and engineering data before another system, the telemetry modulation unit, sends that packaged information home. Think of it as the craft's note folder. The instruments write notes. The FDS puts them in envelopes. The radio system drops them in the mailbox. If the folder gets scrambled, the mailbox still works, but the letters become gibberish. That raised the fifth big question. Was the spacecraft sick, or was the messenger simply mangling the message? Engineers at JPL and the Deep Space Network had to work with almost absurd patience. On March 1, 2024, they sent what the team called a poke. Not a reset, not a rescue slam, a poke. The command was meant to nudge the FDS into trying different software sequences in case the problem could be skirted rather than directly repaired. Because Voyager 1 was then more than 15 billion miles away, it took about 22.5 hours for the command to reach the spacecraft, and another 22.5 hours for the response to come back. On March 3rd, the team saw a new kind of signal from one section of the FDS. Scientists expected either the same gibberish or no meaningful change. What they actually found was still not the normal format, but it was different enough to be promising. It was like hearing one clear word inside a phone call full of static. An engineer with NASA's Deep Space Network helped decode that strange new response. Buried inside it was a readout of the entire FDS memory. That was huge. The FDS memory contains its code, the instructions it follows, along with changeable values called variables, and pieces of science or engineering data waiting for downlink. Imagine getting not just a broken sentence from a locked computer, but a rough dump of the whole filing cabinet. At that point, the mystery stopped being blind and started becoming traceable. The dates matter here because they show how painfully slow this detective story really was. Command sent March 1st, signal seen March 3rd, engineers working to decode it on March 7th. By March 10th, they determined that the strange response contained a memory readout. Every step took days, not because the team was slow, but because the spacecraft was so far away that even light had to budget nearly a day for each trip. Your home Wi-Fi hesitates for seconds. Voyager makes you wait by the calendar. Then the sixth discovery changed everything. Engineers traced the core of the issue to corrupted memory in the flight data subsystem, likely tied to a failed memory chip. Only about 3% of the FDS memory was affected, which sounds small until you remember how tightly old systems are packed. Scientists expected that losing a slice of memory so deep inside a 1970s computer might end the mission, or at least cripple it beyond repair. What they actually found was a narrow path to a workaround. The solution was not to replace hardware. Of course it was not. You cannot send a technician 15 billion miles with a soldering iron. Instead, the team decided to divide the affected code into sections and move those sections into different places in the FDS memory. That is a wonderfully human fix. Not throwing the broken house away, just moving the furniture, rerouting the wires, and writing new labels on the drawers so the whole home can still function. On April 18, 2024, the team sent the relocated code responsible for packaging Voyager 1's engineering data to a new spot in memory. Again, they waited the full light time delay. On April 20th, the answer came back. For the first time in 5 months, they were able to check the health and status of the spacecraft. Scientists expected maybe a partial improvement. What they actually got was proof that the workaround worked. It was like hearing the heartbeat on a monitor after a room full of people had been holding their breath. That moment matters emotionally because it shows what space engineering really is. It is not only rockets and launch pads. Sometimes it is a group of people studying a machine older than many of them are, reading strange memory dumps, and talking to it across a distance so absurd it almost becomes poetry. A refrigerator light uses about the same power scale we talk about in parts of this mission, and yet from that tiny budget came one more clear whisper from beyond the planets. And still, even after the engineering data returned, the story did not become simple. The models had predicted one kind of old age decline, a clean fade, a few instruments lost, maybe an orderly final silence. Instead, Voyager 1 kept doing something more interesting. It kept half failing and half teaching. The universe around it also refused to behave like a blank stage. Plasma waves, density shifts, magnetic clues, and structured regions kept showing up. The machine was wounded, but the science was alive. Do you know one person who would love this story enough to send it their way right now? Sharing helps this video reach the viewers who genuinely care about deep space science before it gets buried under faster, louder videos. Because the strangest part of Voyager 1 may not be the computer glitch at all. About 2/3 of the way through this story, we hit the deeper mystery, the part scientists will tell you they do not fully understand yet. Voyager 1 is not only revealing how hard it is to keep a nearly 50-year-old spacecraft alive, it is also revealing that interstellar space near us may be more textured and more active than older models suggested. Scientists expected smoother conditions over long stretches. What they actually keep finding are hints of structure, pressure fronts, and organized changes in density. This is where the mission stops feeling like repair work and starts feeling like listening at the wall of the universe. Nature Astronomy published results that helped show persistent plasma activity. NASA science updates describe density measurements that were making waves, literally and scientifically. The local interstellar medium was not a dead calm pond. It was more like a dark sea with slow swells you notice only if your boat survives long enough to feel them. Voyager 1 survived long enough, and survival itself was becoming harder. Each Voyager loses about 4 watts of electrical power a year. 4 watts is tiny, about the power of a small light in a refrigerator. Yet when your total budget is already razor thin, losing 4 watts each year is like living on the last bills in your wallet and watching one more slip away every birthday. Over time, NASA and JPL had to turn off heaters, systems, and then instruments, not because the mission was unimportant, but because every watt had to be argued over. By 2025 and 2026, the power choices became painfully sharp. On February 25, 2025, Voyager 1's cosmic ray subsystem was turned off to save power. On April 17, 2026, engineers shut down the Low-Energy Charged Particles Experiment, or LECP. Scientists expected that by this age the craft might already be mute. What they actually had was a spacecraft still operating with 2 science instruments left: the plasma wave subsystem and the magnetometer, both still returning data from a place no other human-made object can study directly. There was another scare on February 27, 2026, during a routine roll maneuver. Voyager 1's power levels fell unexpectedly. That matters because if the power dips too far, the spacecraft's undervoltage fault protection system can begin shutting things down on its own, which creates a long, risky recovery process. Engineers expected the planned maneuver to behave. What actually happened was a warning shot, the kind that reminds everyone just how narrow the margin has become, like hearing the house heater click off in deep winter and hoping it starts again. Kareem Badarudin, Voyager mission manager at JPL, said shutting down a science instrument was nobody's preference, but it was the best option available. That sentence should land hard. These are not casual choices. The LECP had been operating almost without interruption since 1977, close to 49 years. Yet one part of the instrument, a small motor that spins the sensor in a circle, was left on because it uses only about 0.5 watts, and the team wanted the option of reviving more capability later if possible. That is how fine the math has become. Not broad mission planning, but half a watt here, a heater there, 3 hours and 15 minutes for a shutdown sequence after a 23-hour trip through space. The team is now working on an energy-saving plan nicknamed the Big Bang. The idea is to swap a group of powered devices at once, turning some off and replacing some with lower power options, trying to keep the spacecraft warm enough and awake enough to continue collecting data for as long as possible. And through all of this, the distance keeps growing. NASA says Voyager 1 will reach 1 light day from Earth on November 18, 2026, at 2:16:07 a.m. Pacific Time. That is 16,094,799,096 miles from Earth, or 25,902,068,356 kilometers. Scientists expected earlier generations to be amazed if we reached the outer planets. What they actually built was the first object that will stand a full light day away, meaning even light itself needs a whole day to make the trip. Your kitchen timer counts minutes. Voyager measures waiting in dawns. What detail in this story would you want scientists to keep chasing next? The failing computer, the strange plasma hum, or the fight to save every last watt? Your comment helps me understand which mysteries deserve the deepest follow-up on this channel. Because the truth is, Voyager 1 is still not done surprising us. Here is the part that flips the whole story on its head. We began with a spacecraft sending impossible-seeming data, and it is tempting to think that means the machine is simply coming apart. But the longer you sit with the evidence, the less satisfying that simple answer becomes. Yes, parts are failing. Yes, the memory chip problem was real. Yes, power is draining away. Yet at the same time, Voyager 1 keeps returning clues about a region of space we still barely understand. So what exactly is getting stranger? First, the machine itself is aging in ways that do not always look like clean failure. One system can appear impossible while another quietly does its job. Second, the space around it is not the blank black background many people imagine. It hums, it shifts, it has density and structure. Third, the mission has become something nobody planned for, a daily negotiation between breakdown and discovery, between failing hardware and fresh science. That tension is what makes Voyager 1 feel less like an old probe and more like a living story. Not alive in the biological sense, of course, but alive in the way a violin is alive when someone still draws music from it after the wood has aged and cracked. Every new signal asks 2 questions at once. What is wrong with the instrument? And what truth is the instrument still catching, even through the noise? Those are not the same question, and mixing them up hides the wonder. We also need to be honest about the limits. Scientists do not fully understand every pattern Voyager 1 is seeing in interstellar space. The models had predicted something different in some cases. Some results open doors rather than close them. That is not weakness. That is how real science sounds when it is close to the edge of knowledge. Not a trumpet blast of certainty, but careful words, exact dates, measured doubt, and then one more patient look at the data. Think about what this means on a human scale. A machine launched when Jimmy Carter was president is still talking to us. It has outlived the age of vinyl, the first home game consoles, the rise of the internet, and entire generations of phones. Yet it still matters because it is somewhere no newer machine has reached. In a world that treats everything as replaceable, Voyager 1 keeps proving the value of repair, patience, and listening. That may be the strangest lesson of all. When this story opened, the image was an old metal insect whispering where nothing should have a voice. Now the picture is clearer. The whisper was never just a glitch in the dark. It was a sign that both the machine and the darkness around it were more complicated than we guessed. We expected the void to be mute and the craft to be fading. Instead, the void hums, and the craft, even while failing, still answers. A dictionary might tell you that empty means containing nothing. Voyager 1 has spent years quietly correcting that definition. Empty, out there, still holds plasma, pressure, magnetic fields, and thin rivers of information. Dying, for a spacecraft, does not always mean silent. Sometimes it means speaking in fragments, forcing the people back home to become better listeners. That is a beautiful reversal. We thought we sent a machine to study the dark. In the end, the dark is teaching us how to study. A few people once knew where Voyager 1 was and why it mattered. Now all of us have a reason to care, because this tiny survivor carries a lesson bigger than spaceflight. The universe is not required to become simpler just because our tools get older. Sometimes the oldest tool becomes the one that reveals the newest truth. Sometimes the faintest signal, weaker than the little light inside a refrigerator, carries the most important news across the largest distance. And maybe that is the image to carry with you after this ends. Far beyond the warmth of the sun, farther than any road, an old spacecraft still keeps its dish turned toward home, still waiting almost a day to hear us, still taking almost a day to answer back. Not because it was meant to last forever, not because the universe is easy, but because somewhere in the cold, against all expectation, something we built is still listening, and the silence is not silent at all.